All right, so we gotta talk about Android development for your extra credit for CSC200 class. So let's say things that we need to learn first. Okay. So we gotta talk about how to add Android SDK, pretty much just the standard development kit, just like when we do JDK, right? For Java, right? We can use Intellij, okay, to Intellij idea, right? Then we can develop from Intellij idea right here, right? So let me talk about that first. All right, so this is just an Android project in Intellij. How do we create one? We just go to new, right? Project. But if you create new project, clicking Android, you see an error message right there at the bottom. Say that you're missing the SDK. You could do that now with your Intellij. You see that, which you supposed to link the library for that first, which is the Android SDK. So you could go to download Android SDK, right? So far I tried to find a good location for that. I didn't get any luck yet. But what I did is I got the whole Android Studio. When I download that, it just comes with its SDK too. I mean, Android Studio is where you can develop the Android too, or you use Intellij to develop too, right? So if you go this route, like download the Android Studio, the Android SDK should be located under your user, and let me see, app data, right? Local. You probably have to type app data because it's hidden folder, and Android. So this is the Android SDK. This is the path to it, just like I show you the path to JDK, right? So you just need to remember this path and just copy this path, right? Let's say we go the route with download the whole Android Studio to come with the SDK, and SDK for that is in this path, right? And now we will go to create Android project. Before we can do that, we have to go to add the Android SDK to the library, which go to file, project structure, and then this is where you can add the SDK, right? You can go to new and hit on Android SDK and probably just provide that path and hit OK. Once you hit OK, then you should have your Android SDK added. Now I'm going to hit cancel because I already have my Android SDK. Okay. So if I delete it, maybe I'll show you again from scratch. Like now, I remove it. If I create a project, it didn't pick up. So let me add Android SDK. Then hit OK. It's going to pop up that create new Android SDK. Hit OK. It's add the library for you. Now you're ready to develop the Android on Intellij. Okay, just like setup JDK, right? Now we can start to create an Android project. New project. You can switch from Java to Android now, right? And this is just the name of your application. So what we gotta do, we gotta do this for today, 3.5, right? Now we interesting color here. So we're going to develop an application using switch case. Okay, I think we're done with 3.5. Sorry, 3.6, right? So we're going to develop an application and learn how to use enum, right? So you, like I said, this one you pretty much just going to use JavaFX combo box that we have learned and use switch case. You learned how to use switch case last time. And you gonna use the option pane, which is I provide the code for that. Okay, but this time I'm going to show you extra credit. After you have done this, you do extra credit, right? With Android. Alright, so let's look at what we try to develop. Application to prompt user with the option pane, show input dialog box. So we're going to run application with Android to show the dialog box, right? Or combo box. So we're going to use, yeah, either this one as a selection option to prompt the user to select a month from the list of the months in 1 year. So we're going to have the list of January to December, right? Alright, so after user select, then the program is just going to respond with the message according to the month that the user select, correct? If it is December, it's going to say, do you want to build snowman, right? And so on. Alright, so we understand what we need to develop. So I just show you how to link Android SDK to Intellij, right? Okay. Now the next step is just make sure you know this path, right? C. Let me paste the path for you. Okay. Like this path was just gonna be user, right? Username. Download Android SDK. So let me provide a link for you. So from Android Studio, pretty much like I said, I didn't get a chance to find a good link to just get the SDK without the GUI like Android IDE yet. So just use that one for now. Unless you find, let me know the path or the URL to that. And then set, right? I mean add Android SDK, right? Using the following path to Intellij. Project structure. Okay. So that's how you do that one. All right. Now we're ready to develop, correct? That was, we understand the question. So the next step is we're going to show you how to develop, right? An Android application. Now the question is going to be, once you develop, where to run, right? But let's see. So we go to create new project, right? So we're going to change to what type of project name here, like greeting or season? Okay, because it was seasoning, right? Season app. Okay, something like that. Okay, so I named that project. So I leave the rest. This is pretty much just company domain name. Like, let's do nvcc.edu here for now. This is project location, and this is pretty much just like which version of Android you running. So I'm gonna use the Marshmallow. So by the way, before I move on, you probably want to select the one that you have on your phone, the same version. Then you can test on your phone. So let's see what version you have on your phone. Then I can test on your phone. You have Android, right?
No,
You?
I don't even know.
Okay, what version?
How do you check it?
Huh? Check and let me. What?
It's like
7? Alright, let me get the Nougat, right? So I'm gonna get that one. Alright, so now we're gonna have a template, right? So this pretty much a lot of like template that you can use. So what we're gonna use is we're gonna use empty activity for now. So in Android we're gonna create a main. This is like a main activity, just like your main method, right? And I start to create a Gradle project. So now let's look at what is Gradle project, right? So it is a build system, right? What is a Gradle build system? Gradle is an advanced general purpose build management system. Okay, based on Groovy and Kotlin. Gradle support the automatic download and configuration of dependencies or other libraries. So it support Maven and Ivy repositories for retrieving these dependencies. So this allows using the artifacts of existing build system. So support multiple project and multi-artifacts builds. Gradle has the notion of projects and tags. Alright, so what is again? It is pretty much just, remember when you run application, you need the libraries, right? Like the first library that we use is JDK, because we've been using like scanner. We look for scanner from there, right? Or we use math, right? We use like JavaFX. Those are libraries, correct? And now we try to develop Android. We download the library for Android, right? The SDK, right? Now, sometimes when you use it, they also have other libraries that the project that you create is depending on. When you build, meaning like when you deploy your application. Like so far, you never deploy your application yet, right? Like you've been running the project, how you run the project. You hit you either Java C and then Java to run, right? Which in the real world application, you don't have to compile and run every time, right? You're just going to build, mean you're going to create like an icon that you can just launch from that widgets, right? So that is something that we rely on the build, right? Software build. When you build, there's so many programs that you can use. So what first, since we learned how to develop, right? So let's talk about when you write a program, we have to build, we have to test, and then we can deploy. Right? Like there are many programs that you can use to build. Like for example, let's look at, we can build with Maven, right? Like Gradle is one, right?
Welcome to Java Build Automation with Maven. I'm Peggy Fisher.
So let's
and my goal
see
is to
this
introduce
tutorial a
you to the
little bit to
process of using
understand
Apache Maven as a build
what's
automation
built.
tool.
Okay,
For this series, I'm going to use the programming language Java, but Maven can also be used with other languages.
Pause this, and I need to turn on the audios. Right.
Such as C, C++, PHP, and Scala, for example. Some documentation refers to Apache Maven as strictly a build tool, but it is so much more. Maven can manage a project lifecycle, make the build process easier, create reports, and it provides a central document repository, the Project Object Model, or POM. The goal of Apache Maven is to...
1 second. I don't think we can hear anything, huh? Let me test with the other. We just try to go to see. Let's talk about Gradle. No sounds. It could be because I have my microphone on.
Hello and welcome to A Gentle Introduction to Gradle. I'm Tim Berglund, a trainer, author, and speaker on Gradle and other topics. If you're watching this, I'm assuming that you're interested in learning what Gradle is all about. Maybe you know a little something about it. And you probably know something about the build ecosystem that already exists in the Java landscape, including popular tools like Ant and Maven. Now, I'm going to spend most of our time talking about Gradle itself, but there's a question I always like to answer up front, namely,
why would we introduce another build tool? Well, there are a few reasons for this. Number one has to do with some of the tensions that the community has been feeling with the existing solutions. They're very good at what they're designed for, and each of them, those being Ant and Maven, have introduced key innovations into the build space. But as we move forward from perhaps where builds were a decade ago to where we see builds going in the next 5 to 10 years, there's a few pressures. Number one is the pressure for customization. Builds in an enterprise context don't tend to look that much like one another. There's a very simple, if you think of the simple sort of Java template for a build, which is a project I'm going to live code in front of you. We'll build a really simple Java project today. It's really easy to get that work done. But when you expand from that simple self-contained Java project to a profoundly multi-module build that spans lots of different teams and technologies, that tends to be a fairly custom thing, and actual code gets written as a part of that build. The build isn't sort of a quick and dirty little activity that helps us get on to the business of serious software development, but it's its own domain of software development by itself. And that becomes clear, nowhere clearer than in the enterprise, where there's lots and lots of custom work done on builds. And that's really the state of affairs right now. As we look into the future, from complex enterprise builds today to complex automated deployment pipelines tomorrow, and this is something that some people in the enterprise are even experimenting with right now, the idea of continuous deployment and software where there isn't just a build server that builds the code and runs the tests, but perhaps when the tests pass, does some kind of automated deployment to actual production hardware that your business relies on. When we look to that world, the future world of increased deployment automation, again, you have even more demands on the build tool and an environment really that is hyper customized. So I hope to show you throughout the course of this webinar how Gradle delivers on the need to build simple things in an easy way, but also gives you a path, gives developers on your team a path to build custom build standards that can be anything, any sort of deployment environment or automation pipeline that you can think of. Those can be made into Gradle customizations that users of the build can think about and express in a very simple way. Again, there's always this tension between the declarative and the imperative. And this is something we're going to see in the demos that we get to in a few minutes, come out in a few different ways. It's easy to look again at the legacy Java world build tools of Ant and Maven to express the difference between a declarative build and an imperative build. A typical Ant build, which I'm sure a lot of you have seen and are used to, is a very imperative thing. To express build activity in Ant, you script a series of tasks. You describe in an imperative way what the build should be doing in a step-by-step fashion. By contrast, in a Maven build, that's a very declarative thing. And this is one of the great innovations that Maven brought to the world after Ant had achieved some popularity, which is that we didn't have to necessarily describe in this step-by-step way that could become very pedantic in a large build. You might have thousands of lines of XML in this big Ant build file, saying over and over again things that you might wish to be able to express in a simpler way. Maven said, well, really what we ought to do is just kind of configure the parameters of a build and have the machinery, the actual building activity, all that imperative stuff be going on underneath, inside the engine, things Maven is doing or Maven plugins are doing. And inside the Maven POM file, we'll simply declare kind of parameters about the build and have those be interpreted by the engine. So there's this tension between the idea of an imperative build and a declarative build. And if Gradle as a technology has an opinion, it really is that declarative is where you should be. A good build is a declarative build. And that's always our goal. We don't want to see lots and lots of code in a build file, or certainly not lots and lots of XML. You know, that's not a readable thing. And a great deal of code inside a build file can be difficult to maintain, difficult for tooling to access it, and difficult to test. And there's all kinds of dangers there of putting lots of imperative code in your build. So we definitely like the declarative approach. But the problem with too much of the declarative approach is that now there's a tension between the conventions that our declarative build system will afford us and the adaptability of the build. And I hope to show you this again as we get into the demos. Gradle wants your builds to be declarative. It thinks, you know, really that was the right way to go. But if a build has to be declarative all the time, and there are few opportunities to customize the kinds of things we declare, then that implies that the build tool is going to have a strong set of opinions about what the conventions of a build ought to be. In other words, the tool is going to have some kind of abstraction that exposes to you, saying, here's what all builds ought to look like. And we'll just let you configure some parameters about how those builds run. And that works up to a point, but typically as builds become more elaborate and more complex in an enterprise environment, as software grows and as the needs of the deployment pipeline grow, the tool has a hard time keeping up with the development in the build and the complexity of the build. So while we like this idea of conventions and simple and declarative builds, we also want to make the tool adaptable, and we want to give your software development teams, or you as a developer, the ability to extend that tool and build your own brand new conventions. See, Gradle doesn't think that it can imagine all of the build conventions that ought to exist ever. It can imagine a good base set of build conventions, which it gives you. And from that point on, it gives you a toolkit to develop your own conventions and your own language to be able to describe them. And with that, it would be good if we could have a look at some actual Gradle builds. The fundamental unit of build activity in Gradle is a thing called a task. And if you're familiar with Ant, this is a lot like an Ant target, but it turns out to be a much, much richer idea. So I'm going to go ahead and break into some actual Gradle code here. And I'm going to rely on you in the questions or in the chat to let me know if you need a font size increase or anything like that. I'm going to assume that everything is in good shape. But let me go ahead and create a Gradle build. I'm going to be doing this just as a text file. No tooling yet. We'll see if we can introduce maybe Eclipse or Intellij IDEA a little bit later. But right now, we're just going to be playing with some basic tasks in a very simple Gradle build file. Now, the most simple Gradle build I could possibly think of would look like that. Now, of course, that build doesn't do anything. But what that does is that declares a thing called a task. And a task, being the basic unit of build activity in Gradle, is also an object. And that's an important lesson for us to take a look at. Here, I'm going to, since we're in code and we're not in slides anymore, I'm just going to make a comment up here that we'll be able to take some notes in for any lessons we learn here. And the first lesson is that a task is an object, which means that a Gradle build is a program. Now, let me go ahead and run this build. It's not going to do a whole bunch. That delay is not Gradle's fault. That delay is actually an external hard drive on the presenter's computer that kicked on, and a kernel level driver there that causes that delay. So you're not going to see that startup delay again. Our apologies for that. So here we are. I've run Gradle, and let me ask Gradle to tell us what sort of tasks we have in that build. I can always ask us, Gradle, I can ask it, Gradle, what tasks are there? And you see right here, I've created a task called Hello World. So that's a valid Gradle build. That does something. It declares this object, but now we have to configure this object and give it something to do, because by default, a Gradle task, of course, doesn't have any work to do. Now, to configure a task, we use this syntax right here. I'm going to pass it this block between curly braces. Groovy programmers will recognize that as a closure, the closure syntax. If you're not a Groovy programmer, you don't have to be. You can just kind of learn this syntax as I go along. As a part of configuring a task, I have a rich task API to access. Because remember, a task is an object up here. And this is going to remind us that a task has an API. In that API, there's a method I have called doLast. I can call that doLast method on this task object and give the task some work to do. A task, being an object, also has inside it a list of activities. Let's just remember that lesson right here. A task has a list of activities. All right, and I'm going to give it something to do. And that something is simply going to be to print out the message, hello world. I'll go ahead and run Gradle again, but this time I'm going to tell Gradle that I want to run the task hello world. See how much faster that startup is? Look at that. All right. So there we are. I've printed out the hello world message, and I think everybody will agree that's totally worth the price of admission. We had a build tool say hello world. All right, maybe you're looking for a little bit more than that. Let me give you a few more ideas in the basics of kind of build syntax and this task API, so you know the fundamentals, and then I can begin to introduce some things like how to build Java code, how to do multi-project builds, how to run tests, interesting things like that. All right, so I've declared a task. I've configured the task with stuff to do. Now, in the real world, we usually have more than one task. We usually have multiple tasks with dependencies. So let me just refactor this build a little bit. I'm going to have a task called hello that does that. And this task I am going to have, it's going to be called world, and it's going to print the message world. So there we go. I think you kind of get the idea that I can run hello, and I can run world, and I'm going to start doing -q, which is going to, since all our builds are just printing messages out, I'm going to have Gradle suppress those lifecycle messages like this thing here and this build successful, which, you know, we all appreciate the affirmation of a successful build. But since we're just printing things right now, I'm going to do -q. That's going to get that stuff out of our hair. All right, so great. We have those two. What I would also like to do, though, is express a dependency. Before world runs, it is going to need to have the hello task run. So I could express a task dependency like that. So now when I run world, I get the hello world task running, the hello task running first, and then the world task running next. I could continue this. I could say, here's a task called hello world, and it depends on a slightly different way of expressing this, world and hello. Now I can go to Gradle. I can run hello world. I'll clear the screen again. And I forgot my -q, but I get those two tasks to run in the order that I need. I'll give you another nice little bit of Gradle shorthand syntax here. Anytime I have a task name that's expressed in camel case, like hello world, where the first letter is lowercase, but words are delimited by uppercase, I can abbreviate the task name like that. That's a nice little bit of command line syntax sugar for you. Sometimes I'll come up with plugins or custom tasks that have really long names like, you know, generate change log or change log sync or something like that for some automated database deployment pipeline. And I'd much rather type something like GCW or CLS or something like that. So a really nice little shortcut to have in mind. All right, so that's the basics of the task API. And where might I go to learn more about that? Because I told you a task is an object, and therefore that object has an API. And if I could assume, I don't know all of your technical backgrounds, but if I'll assume for a minute that you basically come from the Java world, broadly speaking, and have a little bit of familiarity in that world. So if you're giving Gradle, either if you are a Java developer or if you're giving this to a team of Java developers to use, well, there's great news for them. And that is that all of this API, this whole idea of a task being an object and having methods and properties and all these things, is documented. In the default Gradle installation, we have the Gradle build language reference, or what's sometimes called the DSL, or the domain-specific language reference. We can scroll down here, and if you look off to the left, you'll see core types, and here is task. And we can click on task, and I can read about the nature and purpose of that task object. Here are a few examples of how to create and configure tasks. Like we've seen, I can scroll down. There's a nice narrative giving you a good introduction to all the basics. And then we see a list of properties. See, here's depends on. You notice I used that property. I added things to that collection, and I initialized it to be a list of dependencies. I can continue to scroll down. A rich API. There's a day of detailed training, at least, in learning all this stuff. And here we have the task methods. So the details of this API are exposed to you. Notice do last. That's the method that I was calling just to have our hello and world tasks print stuff. So those things aren't magical. You don't just have to know them. They're fully documented here in this great collection of documentation that comes with every Gradle download. So please, if you're a developer, if you're giving this to developers to use, make sure they feel comfortable digging around in this stuff. I'll come back to this theme of this programming documentation existing and how we can dig into this documentation and sort of the appropriate way to think about the layers of abstraction in Gradle. And this, frankly, is a fairly low level of abstraction, right? I'm saying explicitly I've got these tasks and they have this imperative. This is the imperative build mode here. And I said before, Gradle's preference is to be declarative. So this really looks like, to me, if I were to back up a step and think about this, I would say this looks conceptually like an ant build that I get to express in a slightly more friendly syntax. There are no angle brackets unless I want there to be angle brackets somewhere. It looks a little bit like Java. This actually technically is a Groovy-based domain-specific language, but it's still imperative. And we said before we don't like imperative. So let's see what we can do about moving towards a more declarative style in building some Java code. Now, before I make that transition and begin the discussion of plugins, I'm going to pause for just a minute and give everybody a chance to throw some questions at me, either in the chat or the formal questions interface. And I'll address those questions live before we move on to the discussion of the Java plugin. Out because what's happening is before Gradle actually runs the build, and in this case, running the build refers to executing this line and this line, the two print statements. That's what this build is. So to execute this build means to print hello and to print world. But before it can execute the build, it has to figure out what the build is made up out of. It has to build a graph of these tasks. And there is another great lesson for us to learn in this task module, which is that tasks form a directed acyclic graph. So before Gradle does any execution of the build, it builds a graph of the tasks and their dependencies. It's directed, of course, because one task, hello world, depends on other tasks. This does not express that hello depends on hello world, but hello world depends on hello. And world in turn depends on hello, and so forth. So it's directed. It's acyclic in that you can't have one task A depending on B and B depending on A. If you try that, Gradle will slap you gently. On the wrist and fail the build. If there's a cycle in the dependencies, there's no way to calculate what you should do first, and so that graph has to be acyclic. But this graph of tasks is being built up during kind of an initialization phase of Gradles. Technically, it's called the configuration phase, and I may emphasize that again in a little bit. During this configuration phase, Gradle's reading the build file, building the graph. Once the graph is built, it can come back to this command line that says, we have asked for hello world to be run. Now I can go into my graph, compute the dependencies, execute them, and actually run the build. All right. Another person pointed out the difference in syntax between this depends on left shift and depends on equals. And you're absolutely right. I did that completely intentionally. That's two ways of expressing the same thing. If you were to read in the DSL documentation, you'd see that depends on is a collection. So a task can depend on many other tasks, which makes a lot of sense. Now, Gradle, the build file syntax that I'm using here, is actually an elaboration of the Groovy language. It's a domain-specific extension of Groovy. So inside this, if you're a Groovy programmer, if you know any Groovy, I can actually write Groovy code. Hey, glad you're learning about Gradle today. This is a Gradle method definition. Now, this is a perfectly pragmatic way to kind of sketch things and make little extensions and begin to think of your build as a little piece of code that you're writing. Ultimately, you probably don't want a lot of this directly in a Gradle build by the time the build is production ready. That would be sort of like having an all imperative build. But it's important to know and keep in mind that this is Gradle code that you're writing, so you can do this kind of thing. So this is one, pardon me, this is Groovy code. This is one Groovy syntax for adding an object to a collection. Up here on line 14, this is a syntax for creating a list and assigning it to the collection. So this isn't adding to the dependencies. This is saying, hello world, your dependencies are these two things. And the thing in square brackets is the Groovy syntax for declaring a list. So you're right, I use those two syntaxes. Those are available to me because this is a Groovy DSL. All other Groovy syntax is available to you, which gives you tremendous power and flexibility of making a very expressive and readable build. Also, of course, some danger that instead of filling up a build file with 2,000 lines of unreadable XML, you'll fill it up with 2,000 lines of readable but untested Groovy. And through the plugin APIs of Gradle, whereby you can write your own custom plugins, that's kind of how you save yourself from that overly scripted, untested, and difficult to read build file. We want to keep the build file small, declarative, and expressing our build in terms of our own language. A question from Matthias, could I write to go? If I were to run Gradle for some reason with the no daemon option to create plugins of your own that are going to be distributed internally, we'll be looking at the standard plugin. Now there's another great set of documentation, and that's the Gradle user's guide that comes with Gradle. And currently in its chapter 22, it defines the list of standard Gradle plugins. Now those are plugins that come with Gradle. You've already got them. You don't have to do very much to apply them to your build. It's a single line of code. And there's a whole ecosystem of other plugins contributed by open source authors, by commercial product vendors, inside your own enterprise as you're building out your build framework based on Gradle. You are certainly going to create plugins of your own that are going to be distributed internally. We'll be looking at the standard plugins, and particularly the Java plugin. This is going to help us build some Java code in a very simple way. Now, there are some other language plugins right now. C++ is currently considered experimental. Very soon that won't be experimental anymore. There are plugins for integrating with Eclipse, with Intellij IDEA, for running find bugs, for running check style. If you have Groovy code, you can run the CodeNarc quality checker. Lots and lots of built-in plugins here. We're gonna concentrate up top on the Java plugin, and let me give you an idea how this works. To do that, let's create a little bit of Java code. Get up out of this directory, and we'll go into a blank directory and make a little Java project. And I'm going to do this very quickly. Source main Java org Gradle poetry, and we'll call this poetry.java. It's going to be a single file, one line Java code, of course. Yeah, got a little excited there. I didn't want to make a directory called that. I just wanted to make a directory called that. And then we'll open up in here and make this Java program. So here we are. I will say we are in the org Gradle poetry package. Is that right? Yes, org Gradle poetry. And we can consider this a 100-person group pair programming exercise. So if you see me make any mistakes, just throw a comment in the question. So we'll make a class called poetry, and it'll have a public static void main method. And it'll have, let's see, we'll make another method called void, public list, Caesar, very good, and we'll make a list of strings here. So a very interesting little Java program. In fact, to make this easier, I'm going to grab this little Java program from somewhere else. And I'm going to copy and paste that in. That's you'd much rather me do that than watch me type all that, right? I can type that live, but it takes a while. So there we are. We'll import a couple classes, and this method called Julius Caesar is creating a new array list called lines, and then adding a bunch of these lines to it and returning that list at the very end. So it's going to return a little section of a play from Shakespeare. So down here we have the main method, and it will make a new instance of poetry. And let's see, we have Julius Caesar. We'll want to call that. And see, this class should also have a method called emit, which is going to take that lines list, iterate through it, and simply print out every line in it. All right, works well enough. And here we'll say, we'll call P emit and pass the lines from Julius Caesar. So when we run this program, we should see it print out these, what is this, 16 or so lines of Mark Antony being upset that the conspirators just killed his friend. Good enough. Now that's great. There is our poetry.java program, and I'm going to come back here. I'm going to run a command called tree to show you the directory structure of this Java project. Source, main, Java. That looks familiar if you've seen, if you're familiar with the standard Maven directory format. And Gradle thinks that's just great. And then org, Gradle poetry, poetry.java. Very nice. What I need now is a build file, build.gradle. So we've got our poem, or rather our program written that spits out a poem. Now we need to do the difficult work of, here, let's think. What are the things we need to do here? We need a way to compile the Java code. We need to maybe run some tests. We need to copy static resources. I don't have any static resources right now, but I might need some in the future. That's something that my build might need to do. Run tests, format test results. We need to build a jar. We might need to tie all these things together, have some kind of a top-level task that does it all. That's kind of easy. We saw how to do that before. Does all of these things. So, oh man, we've only got 25 minutes left. That's an awful lot of work to do. So I don't know if we're going to be able to do it, but let me try. Apply plugin Java. That's actually all we need. So let's go back to our build here. I'll show you the tree again. We've got source, main, Java, org, Gradle, poetry, poetry. We've got a build file up here. I can simply run Gradle, and let me again run Gradle tasks like I did before to show you, suddenly having applied this Java plugin, I have all these tasks now. I have a task that compiles code. I have a task that builds a jar. Here's one that does all the compiling and copying of static resources. Here's a task that runs tests. If we were to introduce tests, here's a task that builds Java docs. This is great. I'll just run Gradle build. That's kind of the total containing do everything Java plugin task. Here we are, built. Now I'll clear the screen again. I'm going to show you the directory tree. Suddenly we have build with classes. Here's our class file of our compiled Java code. It's built a jar for us. It didn't find any tests, but it tried to run tests and build some formatted output. It's done everything we need. So now I could build classes main if I wanted to do this in org Gradle poetry, a very pedantic way. I can run that program from the command line. And there you are. Man, that's great. Okay, so all that Java work done for us. Let's add a few more things. Number one, This whole business of command line Java, nobody likes that. Okay, that's just not fun at all. So
you can use emulator. You need just to create a new virtual device. If you have Android phone, you can plug it in. Okay, and then after you do some configuration on your phone to allow for developers for debug, you see your phone list here. You can click it and run it. Then Hello World will show on your app, your phone. This is just an emulator, like phone. You can just select an emulator that you need. So we say we're gonna use the 7, right? So it's download all dependency for the 7. Now since we're waiting for that, so if I want to show you if you have a phone that I can use. Okay, if you have USB 2 or not. Yeah, I have the cable here. So, do you need a code to get your phone? Okay. So I'm gonna plug in. This is an Android phone, right? Like we are building for, like I said, that's an option. You can use the emulator. If you don't have Android phone like iOS, you can just use this, right, to run on your machine. Now, I plug in the Samsung device. Okay. So what we gotta do first, I'm gonna show you how we're going to enable. You have to go to settings. Okay. So I'm going to switch to dock cam here. Alright, so let me know if you don't see it when we can turn off the light in the front row here. So I allow the device, right, to access, and then so yeah, you go to build number, you hit it until it says about 7 times. See that? Now what it did is going to turn on the developer mode. So if I go into settings, I should be able to see the developer. Here, developer options show up. After I hit allow, I hit that build 7 times. So now you have that show up. You just need to turn it on, like the debugger on. That's it. Once it's on, then it should be detected on your phone. All right, so we switch back to our PC here, right? So by the way, emulator also done. Okay. Need to install that thing, HAXM. You see, so we have two options now. You can run with emulator, or you can run with, like, I cannot run with emulator yet until I install this, which I may need the admin, but I'll let that in. There you go. Which that's why I cannot use emulator. But if you run on your home phone, I mean home PC, you should be fine. Like in this machine, I don't have admin, right, to install HAXM, which I have to call them. Now let me show you. I'm going to use this one, right? So I need to allow first. All right, so I hit allow from the phone. Now it detect it. Oh, okay. So because remember his Android is version 6, but I use version 7. It's just minimum, right? If we have the same version, if we have version 7, I can use that. So what I have to do, I have to switch the project to version 6. See that? So anybody has version 7? Can I try it? All right. So I just turn that one for you. Then you can test that. Make sense? All right. So do you need a pin to access? Do I need a passcode or?
Oh yeah.
Oh.
Different. Yeah.
You have cable?
No.
Anybody else has 7? You want to try your 7? You have 7 now. Okay. So I need to turn on the option. So allow. So the operator option is on, right? So make sure we have it on, correct? So turn it on, and now I just need to make sure your debugging here is on. And then okay. Then that should be fine now. So the phone always allow, hit OK. Now I switch back to PC. His phone show up now. See that? That's very simple, and hit OK now. Alright. So it's going to load the application. It's loading, like installing like you do the Play Store and download apps. So it's just like directly download that API to the phone. This version. Okay, once it's done, it's going to show up on the phone, which I'll switch back, and you see it's going to show hello world. Okay. It did already. It's, your fingerprint. So you see it say hello world, right? So that's the app that we just do Gradle and run build. Make sense? So pretty much now we are understanding how to test and run your phone, right? Write an app. But let's switch back to your PC here. So this is just understand this. This is like main. Like in JavaFX we extend what application. In Android we just extends app compact activity and just import that. Make sense? Just like your JavaFX, right? And this is called main activity class. And in JavaFX you use start, right? Android we just use on create. And this is like in JavaFX we use stage, right? This is called bundle. Okay. It just represent all the instances from your phone, like at the time that maybe you're running so many apps, so it has to be, yeah, like create the application that you are going to run. Just like you do create the new instance, new object, right? Like we have start and launch, right? In JavaFX. So now set content view. So this is pretty much just linked to the graphic user interface that you have, what, like you try to do text box, button, right? Text field, combo box, right? So this one actually it's use the layout linking to the XML file. Okay, and let me show you that R is under the, so your source code is going to be under source and main, and this is our Java code. This is your main activity here, and this is just location path to the file, right? Like when you import something like that package, right? And resource, this is all the resources R. You have the layout, and this is the XML. This is pretty much just hello world right there. So you don't have to write a source code for the button. You can just drag and drop the button. It's easier than JavaFX, right? So you want text field, you just tap drop. See that? And then now the key is how you're gonna link this, right? So we have ID here, right? So we have find resources by ID, which is the method in main activity. So you just need to know what's the ID. Like this is button. So we just go back. We just need to refer to object like by ID. So let me go back to main activity, and then you can just use the method. Like for example, we use button, right? I just create object button, right? Name button equals to find view, find view by ID, and the ID name is R dot. So what's the ID name again? Button. But you have to know, I think, R dot ID. Yeah, there you go. Button. R dot ID, because that's resource button. And then you just need to import the button, right, from Android. Like JavaFX, you just do JavaFX button, and then you just cast the button object as button. Now we get the button. That's how you link to the XML file that you have the button here. Now you touch that button. Then you can start to do like, remember how we do the button? Dot set on click listener, right? Like you add an action, right? So now you pretty much just need to understand, like normally we use lambda, right? In JavaFX you do like that, remember, right? And then you just do system.out.print here, right? Correct? So but like I said, it's actually coming from, let's look at button on click Android, right? Let's look at the structure of, it's actually coming from the class that I showed you earlier, right? We just embed the class in here. Make sense? So again, you can review the textbook again, this page. It's just set on action and embed the code in here. See that? This is JavaFX version, and this is the Android version, right? It's pretty much called a class, but we just bring all the object of class that we create inside here. So you technically just replace with that E. That makes sense? And then this, you just do import the view. And now you can just do anything that you want, like system.out. And you can put your switch case here and everything in here that you want, like anything about the project, right? Like say, I'm going to say hello world. And I'm going to make it outstanding a little bit when it's printed out, because this in Android is going to print a lot of things. You may not notice that. So let's run it again. Now it's going to go to your emulator or phone, right? Once you go to your phone, I pretty much just going to show you. We will click on the button. After we click on the button, then it's going to say hello world to the console, right? And that's pretty much it, right? So there you go. I hit on the button. So let's check back on the console here. Need to show the bottom of the screen. I need to bring that screen up. Android monitor. Can you, yeah, just click. Yeah, just click hitting the button, keep hitting. I want to bring that. I'm looking for like the console, right? Maybe this one. It's pretty much easier just to do like the pop-up, or we call toast. Let me see, but wonder where's that screen. Let me rerun it. Or we can just rewrite the code. There you go. Application terminated. I rerun it. So since we're waiting for that, I'm going to do toast Android. Toast is just like a pop-up box at the bottom, like a dialog box. Alright, so this is just like the pop-up box. So I'm going to use toast on the Android. Let's rerun. When I click, it should show that. Alright, so we're going to switch back to DocCam. Alright, so see that? It showed the message at the bottom now, right? Yeah, see that? Is it? Yeah, it's like a pop-up box, right? Like I can always change the message that I want. Now I'm going to change to hello world. So it's going to rebuild and show up again. It's still building. Just wait. And I'm going to call the row, and you pretty much can go after that. And you can just experimenting that with the assignment for extra credit. See that? Easy? It's going to be fun now. You're going to build your own app, right? Once you have the basic understanding of Java, alright.